evaluate the integral 15 sine to the fourth 2x dx. So here is the problem, the fourth power. Somehow we need to get rid of this fourth power. Then when we have like sine theta without any power, then we can just do the integral. So somehow we need to get rid of fourth power. So let's break this into squares first. So this 15 can be pulled outside, by the way. Sine to the fourth means sine is square. Now this 15 is outside. Now sine is square. We need to work on this to get rid of this square. We have two half angle formulas. Okay, sine is square theta, and there is one with cosine is square theta. This is 1 minus cosine 2 theta over 2, 1 plus cosine 2 theta over 2. This theta is half of 2 theta. That's why half angle. So we got sine is square 2x. That will be 1 minus cosine 2 times 2x. 4x all over 2. So this one, and we got this quantity square as well. Sine square theta is, I'm saying theta for 2x, 1 minus cosine 2 times 2x, 4x over 2. Look, why are we doing this? Now we don't have that power. This is square, at least is gone. We still have outside, but we'll take care of that. So this square is gone, then we can find the antiderivative. Okay. So the next thing is, now we need to take care of this outside square. This 2 square 4 we can pull outside. That leaves 1 minus cosine 4x quantity square. It's like u minus v quantity square. That is u minus v times u minus v. When we multiply itself, we're gonna get this. So let's do that. This 2 square on the bottom 4, I'm gonna pull that outside. So 15 over 4, 1 u minus v squared, using or multiply 1 minus cosine 4x by itself. You're gonna get 1 minus 2 times 1 2 cosine 4x plus cosine square 4x. Okay, this part is clear. Now we know how to find antiderivative of 1 with respect to x. This is also fine. There is no square cube, but we still have a square here. So we need to write formula for this. Like last time I wrote here, cosine square theta is 1 plus cosine 2 theta over 2. Let's do that. 15 over 4, 1 minus 2 cosine 4x plus, let's say this theta and cosine square theta. That is 1 plus cosine 2 times 4x, 8x all over 2. Okay, and outside we got dx. Now there is no square or anything. We should be able to complete the problem now. Okay, this 2 is not for everything, so cannot pull all the way outside. 15 over 4, antiderivative of 1 with respect to x is just x, minus 2 is 2, antiderivative of cosine 4x. We know that when we have cosine alpha x, that is just sine alpha x, but there is an alpha, that's a number, then we need to divide by that number. Okay, it's a small u substitution. So this one is now then sine 4x divided by 4 plus. Good news, there is a plus, so we don't have to worry about writing parentheses. So we need to separate into two fractions. This is 1 over 2, or we can write 1/2 and inside this, same thing. 1 over 2. Now antiderivative of 1 over 2. It's just 1/2 x plus this 2, this is 1/2, 1/2 cosine 8x. So I'm going to write 1/2 here. That leaves cosine 8x. So I'm going to apply this formula one more time. Cosine 8x is antiderivative of cosine 8x is sine 8x all over 8. Okay, and that's 15/4 plus c, and when we multiply that c by 15/4 constant, we'll get another constant, and we can write that outside, plus c. And this is final, but we can combine couple of terms here. 1 copy of x, 1/2 copy of x. So let's combine those. So 15/4, 1 copy, 1/2 copy. So 3/2 x. And this one is -2/4, because numbers, same as -1/2, because 2 goes 2 times, sine 4x. This is covered, plus this one is now 1/2, 8, 1/16 sine 8x plus c. This is good enough. I mean, the best we can do is just distribute, but that's not necessary. So this is the final answer.